Okay, class, let's sit down and try this question. What impulse is needed to change the velocity of a 90-kilogram football player from 3.6 meters per second towards the north and make it 1.2 meters per second towards the northeast? And then in what direction must this force be exerted? Okay? So I've done a little bit of pre-calculation here and drew the vectors. We have a mass of a 90-kilogram football player traveling at 3.6 meters per second north. Therefore, his momentum is 90 times 3.6, which is 324 kilograms meters per second north. And the final momentum, he's traveling at 1.2 meters per second. So they slowed, whatever hit him, slowed him down by quite a bit, by a third of the speed, down to a third. So his momentum is only 108 kilograms meters per second at 45 degrees north of east, because it's northeast direction. So I've already done a little bit of pre-calculation here as well in light purple, that figured out its components. The x direction of this one is 76.37 kilograms meters per second, and the y direction is 76.37. They're equal because it is a 45-45 triangle. So the question is, what impulse? Now, impulse is known as the force times the time, and in the momentum chapter, that's also equivalent to the change in momentum. It is a vector equation. So what impulse, we could just say, no, with what change in momentum? Same thing. But the change in momentum is the final momentum subtract the initial momentum. Subtracting vectors is a little awkward, so I kind of like doing that's the final plus negative the initial momentum. Add a negative is like subtracting. So negative the initial, and this is the initial, so negative the initial would just make this south instead of north. Okay, visually we can take a look at it. Let's see if I can select these vectors. Okay, maybe I can't. Let's just draw new ones. Oh, now it's selected. Okay, negative initial is straight down, and the final is at 45 1/3. So the resultant is this vector here. So this is negative the initial momentum, and this is the final momentum. And if I add negative the initial plus the final, I get the resultant momentum, the final vector momentum. Or actually, no, sorry, I get the change, not the final. And that's what we're trying to find out, is what that change is. So that's the answer visually. We have to do this mathematically now, and that's not too hard. One of them is just in the x, the other one's in x and y. So the change in momentum in the x direction is just going to be this x direction here. 76.37 kilograms meters per second. Because that's the only vector that is in the x direction at all. And the change in momentum in the y direction is going to be 324 down and 76 up. So 324 down plus 76.37 up. So the end result is 324, subtract that last answer that's on there, the 76. Nice. Oh, here we go. Can I still do it? 324 subtract that answer. So that'll be 247.6 down. So those are the components of that green vector there. So we just have to put them together. 76 this way, 247 this way. So what is the magnitude, the hypotenuse? And then what is the direction? So take that number divided by 76. Let's get the direction first. And then inverse tan that number. I guess I should have probably put more sig figs in there. About 72.9 degrees. So the angle will be 72.9 degrees south of east. And then what is the change in momentum? We have to do it Pythagoreanly. So what is it? 247.6 squared plus 76.37 squared, all square rooted. $259.11. So that's the change in momentum vector, and that's also the impulse. So that's the impulse that's necessary. And then in what direction must the force be exerted? Well, this disappeared, I don't know why. That's the change in momentum. So impulse is the change in momentum. The direction of the force is the same direction. It's a vector equation. So the direction of the momentum is the same as the direction of the impulse, so it's the same answer, 72.9. We can't calculate the magnitude of the force because we don't know how many seconds it took for that tackle to occur.